Hello friends, welcome to risingpearl.com. This is series 13 where we are learning a lot about surface areas and volumes. Friends, this is webisode number 19 and today we are going to focus on transformation from one shape to another. Because this is a series on surface areas and volumes, so our focus will be to learn as one thing is transformed from one shape to another, how does it really affect the surface area and the volume of that thing. So let's look into it. So we are going to begin this webisode by talking about how do we make candles. So I know out of the blue it is very surprising, why are we talking about making candles? But believe me on this, we are going to list out some very high level steps of how a candle is made, and we will try and figure it out how it relates to this particular topic. So the first step of making a candle is we start out with liquid wax, and yes, there is something called as liquid wax. So first step is you take some liquid wax. Second step is pour that liquid wax in various molds. Molds are nothing but containers. Third and final step, you let it dry or solidify, and voila, you have a candle. So what is important, friends, is obviously this is an extreme simplification, oversimplification of how a candle is made. But my point is we start out with liquid wax and we get a solid shape, which is a candle. So what happened is our liquid wax, liquid, got converted into solid. And this is what we are going to focus on, really, how it affects the surface areas and volumes. So let's look into it in a little bit more detail. So say we start out, so I have two containers here, and the liquid which is highlighted in blue is the liquid wax. So imagine this is liquid wax. So I take the same amount. So let's say this amount is V and this amount is V as well. So V is the amount of liquid or the volume of liquid which is in this, which is the liquid wax. Now what I do is I take two different looking containers, and these are my molds, right? So this is my mold A and this is my mold B. They are both of in the shape of a cylinder. This is much more shorter and fatter, or wider, you can say that, and this is much more slender and taller, right? So what I am going to do next is I am going to pour my liquid wax into each of these molds. So I'm going to pour it like this, I'm going to fill it up, I'm going to empty my liquid wax, and I'm done. So now what will happen, friends, is that now in this case, in mold A, the liquid wax is filled in this form, and if we let it solidify, we'll get a candle like this. In mold B, if we let it solidify, we are going to get a candle like this. If you look at each of these cases separately, what is very important to note is that the initial liquid that we started off with, the initial volume, let's say it was somewhere over here, and again the same thing over here, right? So this liquid wax that we initially had, that basically was poured into this mold, and that made this candle. So what is the connecting factor in between these two? So the common factor that binds these two is that this liquid wax, which was of volume V, that made this candle. That means because this is a cylinder, so we know that so cylinder has a radius R, and let's say the height of this is, because we have two scenarios, let's call this R1 and this height as H1. So the amount of liquid wax in this will be given by the volume of the cylinder, volume of this cylinder. So volume of this cylinder will be pi R1 square times H. Now this volume, that which tells us how much liquid wax is in there, because capacity of this cylinder is the volume of the liquid wax in there, that this must be equal to the volume here, which was a starting volume of liquid wax. So very important point, friends, which we are making here is that the volume, when a liquid, in this case starting here, got transformed into solid in here, the volume remained the same. So if we started out with volume V and finally we got a volume pi r1 squared times h, because this is in the form of a cylinder, so these two volumes must absolutely be equal. As the state is transformed from liquid to solid, the volume must be the same. Similarly, as you can imagine here, this was a starting volume, and let's say, because we said this was also V, but in this case we got a candle which is very differently looking in terms of shape and size. So let's say this radius, if this radius is R2 and this height is H2, then in this case volume of this cylinder, which gives us how much amount of liquid wax in this, that volume is given by pi R2 square times H2. Now this volume of the solid, it absolutely must be equal to the volume of the liquid wax that actually made this solid. So these two volumes must be equal. So friends, the point that we are looking to drive at is, as we have transformation done from one state to another, right? When one shape is transformed into another shape, new shape, the volume of the old shape remains equal. Volume of the old shape remains equal to the volume of the new shape. This is very, very important. In other words, this point, that volume of the old is going to be equal to volume of the new, this is super duper important. Each asterisk is for very. So it's very, very, very important to keep in mind whenever you have a transformation from one state to another, that the volume of the old shape is always going to be equal to the volume of the new shape. And as we just saw, the reason of that is because you are using the old shape to make the new shape, right? Because you are not adding anything extra. You take the old shape and you use that to make the new shape. So the volume of the old is always going to be equal to volume of the new. Very, very important to keep this in mind, right? So the strategy in solving questions that are based out of this kind of transformation are, we just have to remember that volume of our old shape must be equal to volume of our new shape. So some types of scenarios where you may actually apply this, they will go something like, say you start out with one shape and you melt it, then a new shape is created from it. So that is one type of question that you may come across. The other one could be like, you dig up some ground, and then whatever the soil that you take it out, you then make some shape out of that soil. So again, it is important to understand how much soil did you dig out, what was the volume of that soil, and then that is the soil that you are using to make the new shape.